Good afternoon. Good afternoon. So I'm at the art gallery today. Sometimes I sit at this art gallery every now and then. And it was raining earlier, and now it's getting sunny again. It's a nice day. So the art today is photography. So I'll go around and show you all that in just a second. If you're interested, I just wanted to share some math that I've been working on. You know, I can't help it. I can't stop. But if anyone has any comments on it or anything, or thanks for listening. So I'm just going to show that as like a screen recording. So hopefully that works. So I'll show that now, and then when you're done, you can come back and get a reward by looking at some art. Okay, see you soon. Okay, so hi everybody. So I just want to go through some notes that I made and some maybe discoveries. So last time we saw that, like, if you look at the product, like the Riemann Zeta version, the product version of the Riemann Zeta function, looking at the primes in m to the minus p, where we kill all the primes, we saw that it's the Riemann zeta function divided by 1 plus the prime zeta function. And so I wanted to see, well, what about if I just eliminate one prime? Okay, so q is no longer a prime. So let's say on this slide here, so let's say, this is going to be great, guys, because I can use this. Okay, so q is fixed. Okay, so that one I don't filter out by. Like in the Riemann zeta, the proof that the product equals the sum, we filter out by all the primes. And so you can see when we can't filter out by all the like ground model primes, they're all left over. And so, but if we just can't filter out by one of the primes, just that term is left over. Okay, and I didn't show the proof here. I think I wrote it on my whiteboard, but like, I believe that this is true. Okay, and it kind of makes sense. But okay, so let's say I just want to see like a better form of what this is. And so let's just divide doing long division. I think this is correct, but what it looks like happening is that first we multiply, one goes into one, we multiply, subtract, and so the q to the minus x is going to be canceling out, and then we multiply by the 2, and so the 2 to the minus, those cancel out, and so on. So 1 over q to the s is gone, 1 over 2q to the s is gone, and so on. As we keep going, it seems like we get this Riemann zeta function where we're missing all of the 1 over k q to all the multiples of the q that we killed. Okay, so this is what I think is the case for if we just kill one prime. So if we just kill the prime q is fixed prime, then I think we get the Riemann zeta function, except for all the n's that are multiples of q. Okay. But so then the question is, so that it seems like if we keep going, it seems like, well, then if you kill all the primes, you're going to get 1 over n to the s, as long as n is not a multiple of any prime. But the only thing that satisfies that is 1. So I was like, what's going on? That's just 1, but I know it's not just 1. And also, like, I think I calculated this for some of the s's. I have to admit, you guys, I started using AI at this point. Because I just was like needing some like I'm like just like a little bit of evidence, and I was like, well, I asked AI what this is, because I could just say it in words like the zeta function divided by 1 plus the Riemann the prime zeta function, and like it understood what I was saying, and it's like as a limit, and it said 1. I was like, oh yeah, that makes sense, because if you look at this, it has 1. And all the other terms are going to go to 0 and stuff like that. So it makes sense. But I was like, oh, yeah. So I have to admit, I did start using AI for just like checking some intuition. Okay, so this is 1. On the other hand, it's this, but that goes to 1. And it doesn't actually equal 1, but because if you calculate this for different values of s, it's like for s equals 1, it's like, like negative 1/2 or something. Okay, again, I asked AI that question. Okay, I thought maybe this. Okay, so anyway, so then I started. Okay, so basically, it's like it's not actually equal to 1, but it goes to 1. It converges to 1, which is the same thing as the Riemann zeta function. I mean, the Riemann zeta function also goes to 1. It's not, it's just, I guess it's just has to be that way, or it's just interesting to see. And like, also I was like, oh, I want it to be more satisfying and more interesting. And it's like, okay, well, it does go to 1 if that seems satisfying. Okay, then I was just like, I was thinking about even primes, and yes, there are definitely infinitely many even primes in m to the minus p. And as long as you kill 2 and infinitely many other primes, you can get infinitely many even primes. Some professor told me that there's a book that says the list of even primes, and it's like a joke book, but that's so funny. They said that after I gave my talk. Okay, so I just wanted to see, like, maybe for every twin prime over here, you know, there's a twin prime pair that can be found in here, you know, like, oh, look, there's 2, 3, I was counting 2 and 3, but let's just say 5, 7, oh, look. And it's like, yeah, that's happening. So, but it looks like, I mean, these contain twin primes, but there's no like a twin prime pair in the factorization of this pair. Okay, this is just for fun. This is like another way, you know, just like another, you want to think philosophically, sometimes think number theoretically, sometimes it's just fun. Okay, but I think the twin primes did show up, every single one of them. Not counting 2. There was 10 twin primes in m to the minus p, in v, and 20 in m to the minus p, less than 119. Okay, and I have to admit again, so I did use AI, because I know that it might not be all correct, but at least for this it was easier to use than like, I need to like maybe learn how to maybe make a program or something, but I could look up like Wolfram Alpha, like, oh, what are the squares of primes, or what are the square free numbers that aren't prime, but it just understood what I was saying, and it gave me these, so, you know, we wouldn't include the 1 in our list of primes, but these would be the primes, these are the primes in m to the minus p. And I just want to make a graphic of like the distribution, assuming these are in there, I can check. I want to make a graphic of this compared to the time distribution. Okay, so that's it. And so thanks for watching this little, okay, welcome back. How was the math? Did you like it, or just like, okay, or just like, pretty good? Pretty good? Okay. So first, this looks kind of cool. I like this juxtaposition. I like the colors in the black and white. Okay, let's just go around looking at the art. I didn't look at the artist stuff, you guys. I just just gonna show real quick. So what's back here? We've got some train. It's like a shoreline, okay. Like the reflection, reminds me of like Escher. Okay, super nice day. Frame of mind. Okay, looks like some New York scenes. 232 Madison. Okay. Got some other kind of New York scenes here, I think. Yeah, this looks like a New York subway to me. Okay, I think this is all the same artists. I don't know. I really like this one down here. This is cool, like just the kind of captures something. I like the light colors. Okay, I think these are nice. These are all really big too. I really like the big frames. Okay, look at this one. This one's really cool looking. Yeah, it's really cool. It's a lot of colors going on, and you know, it's such a simple subject. Got some more of these. I've been kind of staring at these guys while I'm working. This one, I think this might be my favorite. Love this one. I love seeing those colors in the rocks like that. Let's see, I don't know where this is. Maybe me, I don't know. Okay, we'll come back to these ones. Oh, these are great. They're all great. I like this colors a lot. Really like these two together. It looks like a dream. Like maybe this is like definitely like a dream I had. Okay. What is this, New York City? It says the New York something. Yeah, it's gonna be New York. Oh, frame of mind. Maybe it's like state of mind. Yeah, I don't know, something like that, you guys. Cool, cool, cool. Cool, cool, cool. Oh, this is good. Oh my. Now, doesn't that look like, looks like it's gonna be an insert in like a Jane Eyre book or like Jane Eyre. I don't know, it's that black and white color. It's like, ooh, what's gonna happen? Okay, so thanks so much for hanging out. And I hope you like the math and the everything, and thanks for hanging out. You know, I'll be back probably soon. And good luck with all the stuff you're doing as you're working on. Okay, see you soon, guys.